This is the first of 3 problems that you should know how to do. This one says that assume the United States national debt can be estimated with this model, the equation, where X represents the number of years since 1900 and Y represents the debt in billions, billions of dollars. So this billions times rate, X number of times, years since 1900, gives us Y. According to the model, when did the debt pass 1 trillion, which is equivalent to 1,000 billion? Well, you can write in 1,000 is equal to this value times this rate and solve for X. Now recall that this is an exponent, so this is the first thing you do in evaluation or evaluating an expression or an equation. It's the last thing you're going to do if there's also multiplication involved. So using reverse order of operations, we divide both sides by this amount. So this is approximately 481 and 70 or 7/10. That's equal to this value, and I'm going to do approximately that value and hope that's going to be close enough, raised to some power X. Now, you have this in exponential form. To solve for the exponent, you need to write it in logarithmic form. So recall that your argument is equal to your base raised to the exponent. The equivalent form of this is log of the base, the argument equals the exponent. So now let's use logarithms to figure out what X is equal to. First of all, we need to choose the change of base rule because we don't work in logs of base 1.083. So we can use base 10 or any other log base to write it as log of base 10, or just plain old log, of our argument A divided by the log of our original base and that's going to give us X. Now remember, X is the number of years since 1900. So it's asking you what year approximately did this model show us that the debt had passed $1 trillion. Well, if I type this into my calculator, I get approximately 77.1. So if X is the number of years since 1900, then somewhere in 1977 is when a national debt reached passed $1 trillion. Part B of the question. According to the model, what is the annual growth rate of the national debt? Well, you can find this inside the parentheses. This is 100%, and anything more than that is going to be the growth rate. So we're looking at a growth rate of approximately 8.3%. Recall how to change that decimal into percentages. Part C, what's the doubling time for this growth model? Well, if it doubles, then your initial value is going to end up being double what that is. So simply replace y with double this value, or once you get a habit of doing these problems, you'll notice that if you take any ratio between two consecutive terms in a sequence, you're always going to have 2 if it's doubling. The doubling is equal to the rate for the multiplier raised to x. The doubling time is going to be in years. Now recall x in the original problem was years since 1900, but it's going to double and then double again and double again. That can be found by figuring out this value x, which is the number of years, and you solve that in the same way. Use logarithms. And you should be able to find that log of 2, log base 10 of 2 divided by log base 10 of this rate is approximately equal to 8.65. That's years. So every 8.5 to 8 3/4 years, 8 2/3 years, however you want to describe it, approximately is the time doubling. Sorry, is a doubling time. Problem 8. I'm going to post this so you guys can try this on your own. I'll put the solutions into the text. Oh, sorry, I'll put the solutions inside your assignment. I'm not sure how I'm going to do that so I can hide them and make sure you guys try them first, but I will post those probably at this evening or tomorrow. If you can find these as problem number 8 and problem number 9 in the lessons, you're welcome to do so. Try problems 8 and 9 and get back to me with the solutions. These problems are very much like the ones you'll see on your assessment. And I hope to have you guys test. It'll take about 15 minutes to do these problems. I hope to have you assess on Friday.